Circle theorems, part 2. You may have already watched the part 1 on this, showing the first 4 circle theorems. In this recording, we will be looking specifically at the tangent theorems. So, the first tangent theorem, if you have a radius touching a tangent, this creates an angle of 90 degrees. Let's just look at this one example together. So, here. Oops. Here we have a radius, here we have a tangent. So our angle here is 90 degrees. And then you probably already spotted that we actually have a triangle here. Angles in a triangle add up to 180. So our missing angle X is 63. Have a go at these 2 questions yourself. Put me on pause, unpause when you've done to reveal the answer. So again, from this one here, we have a radius touching a tangent. So this angle here is 90 degrees. Angles in a triangle add up to 180, which gives us this angle here is 22 degrees. So angles on a straight line add up to 180, which gives us the missing angle here is 26. We know now this is 90 degrees. Angles in a triangle add up to 180, which gives us this angle here is 64. And then here, can we see the straight line? Angles on a straight line add up to 180, which gives us this one here is 116. Okay, so let's look at our third tangent, our second tangent theorem. If you have 2 tangents that touch outside your circle, then from the point where the tangent touches your circle, those lengths are the same. So here you can see this length there is the same as that length here. Okay, how about this? We've got 2 tangent theorems in one here. We know that these are both 90 degrees. We know angles in a 6-sided shape add up to 360. So if I take all of those other angles off 360, we get X is 22. I didn't really use the fact, though, that these lengths are the same, but you should see that come up in the next question. Yes, okay. Have a go at these 2 questions and see how you get on. So again, with this one, we've got a radius touching a tangent, 90 degrees, 90 degrees. Angles in a 4-sided shape and a quadrilateral add 360. Well, this is actually a kite, but we don't really need to know that. 360 minus all of those angles gives us this missing X here as 165. Now here, our 2 tangents meet at this point. So these pink lines are the same length. So seeing if those are the same length, can you see we've got a triangle here? Angles in an isosceles triangle, right? Those lengths are the same. So this angle and this angle here are both 67 degrees. We know, don't we, also that we've got a tangent touching a radius. So that's 90 degrees. That whole angle here, let me put it in a different colour, is 90 degrees. So this missing angle here has got to be 90 minus 67, which is 23. So OBC is 23 degrees. So our last theorem, alternate segment theorem. So if you have a tangent touching a triangle inside your circle, that angle here, so I usually use a highlighter, the tangent touches your triangle there. So this angle here is equal to the angle on the opposite side to that length on your triangle. Let me show you with this one. So we've got the tangent, because it touches the triangle at this point here. I'm going to show you there. So which angle is opposite this pink line here? Oh, it's that angle there, so x is 70 degrees. So here, tangent, touches triangle, 55, 55. And here, tangent touches a triangle, 60 degrees. That opposite one there is 60 degrees. Have a go at these next 3 questions by yourself. Put me on pause, unpause to see how you get on. So here we've got the tangent touching your triangle. Which angle is opposite at the green length? It's this one, so that one's 65. If I highlighted that on the other side, you would see, oops. Not going to highlight it, that one is equal to this one here, so 63 degrees. Y is 63. Angles in a triangle add up to 180. Take those off 180, you get Z is 53. Tangent touching your triangle, opposite angle 64, Y is 64. And tangent touching the triangle, opposite one is 67. A little bit more complicated, this one. Can you see? You've got your tangent touching this triangle here. Let me just change the colour of this pen. This here is the triangle that tangent touches. So it's the opposite angle. Let me just highlight that in green. So it's the opposite angle in the triangle that is 80 degrees. There's that X angle there that's 80. Now, we've got some other theorems here, haven't we? If you notice, we've got angles at the centre, an angle at the circumference. So X is 80. Here's my angle at the centre, angle at the circumference. Angle at the centre is double the angle at the circumference, so Y is 160. Now, if you watch Circle Theorems 1, I gave you a little tip to mark out any radii that you have. That's a radius, that's a radius. It's got to be the same length. So we've got an isosceles triangle, 180, take away 160, divided by 2 gives you Z is 10. I'm going to put one more recording on circle theorems, which we look in specifically exam questions. Okay, thanks.